I wanted to see if I could make a shader feel alive, not through big animation, but through very small, painterly changes that slowly breathe over time. This entire animation is driven by a single sine wave. It loops perfectly and never actually moves any geometry. In this video, I'll break down how I designed it, why it works, and how you can think about motion in shaders without overcomplicating things. The first step in this process is creating a hand-painted texture that simulates the feel of a painting. You can paint one yourself or use a texture you find online. For this project, I decided to paint my own using Krita. The important part here is to make sure that the texture is stylable. That way, when we bring it into Blender and wrap it around the geometry, the strokes stay seamless and continuous. I'll show you how I set that up in the next section. Once the texture is ready, I use it to build a material and map it onto a mesh. Rather than relying on displacement or deformation for motion, I wanted the surface itself to feel alive. So instead of moving geometry, the animation comes from modulating the surface properties like color intensity, roughness, etc. over time. All of this motion is driven by a single time function that loops cleanly. That shared timing is what keeps the animation calm and cohesive, without different elements fighting each other. Using Blender's shader graph, I'm able to use the same rhythm across multiple parts of the material to create a slow, breathing motion that loops seamlessly. Alright, let me quickly show how I created the painterly base texture for this project. I use Krita here, but the exact software doesn't really matter. Photoshop, Clip Studio, or any digital painting tool will work just fine. I'm using a soft painterly brush and focusing on building directional strokes with slightly different intensities and shape. At this stage, I'm not thinking about the final material yet. I'm just creating a texture that feels organic and balanced. How you craft this texture has a huge impact on how the shader behaves later in Blender. One important thing is that this texture needs to be tileable. In Krita, you can enable the wraparound mode using this button here, which lets you paint across the edges and keep everything seamless. Once I'm happy with how the texture feels, I export it as a PNG. I begin by creating a new material and importing the texture we painted earlier. I then connected a texture coordinate node into a mapping node and then into the texture. At this point, I decided that a sphere would be better to showcase the texture and create an icosphere. As we change the mapping values, the painterly strokes tile seamlessly. From here, I add a color ramp and start adjusting the values to introduce some color variation. This already gives us a nice painted base to work with. Now comes the interesting part, adding motion. I didn't want anything obvious or distracting, just a very subtle sense of movement. I create a value node and add a hash frame driver to it. This gives me a time input, which I then multiply by a very small value to control the speed. That value is passed to a sine node, giving me a smooth oscillating motion. By multiplying it again with a small value, I get a slow, gentle signal that moves between positive and negative values over time. I use the signal to influence a noise texture. It is then added to the texture by using an add node as shown here. Tweaking these values lets me control how much the texture subtly shifts and distorts. At this point, the motion looks good, but there's a problem. It's not looping cleanly. To fix that, everything needs to be driven by a sine wave that completes exactly one full cycle over the timeline. You can think of a sine wave like a smooth inhale and exhale. After one full cycle, which is 2 pi radians or about 6.28, it returns to the exact same value. So the relationship is simple. Number of frames multiplied by the speed needs to be equal to 2 pi. In my case, I chose a speed of 0.02. Dividing 6.8 by 0.02 gives me 314 frames. Once I set the timeline to 314 frames, the animation loops perfectly. Now I can tweak the noise values freely, knowing that the motion will stay seamless. Next, I wanted to introduce some very subtle color variation over time. I added a hue saturation value node after the color ramp. Initially, I tried driving the hue using the same time function as before, but even very small values cause the colors to shift too aggressively. So for this part, I actually prefer doing it the old-fashioned way. I keyframe the hue manually, timing into the same breathing rhythm. This gave me much control and the results felt calmer and more intentional. Roughness plays a big role in how alive the surface feels. I start by taking the texture and running it through a color ramp before connecting it to the roughness input. To add motion, I duplicate the same time function from earlier and multiply it with the color ramp made earlier. This creates a gentle breathe in, breathe out effect, where the surface shifts between slightly rougher and slightly glossier over time. I experimented a bit with the order of the operations here, eventually moving the color ramp after the addition and tweaking it until the motion felt just right. To tie everything together, I created a simple world shader that lets me control the background and lighting independently. I also reused the material on a base plane and played around with different color combinations. Some of them were pretty wild, maybe for a future project. I added a simple outline using a solidify modifier and an outline material. Eventually, I switched the base to a curved shape and started thinking of this as something like a water droplet resting on a leaf. And that's pretty much it. The setup itself is quite simple, but depending on the base texture, the mood and the emotion can completely change, almost like a painting. And here's the final result. If you enjoyed this experiment, consider leaving a like and a subscribe for more stylized and experimental content. Thanks for watching.